Yeah, there'll be strictly no fisticuffs over type systems, please. No punching each other over type systems.
The fact is that we can't solve the DZ time stuff because we can't convert a string to name. So we started that and then we have to do this, and it isn't possible for our tool. So we have strictly typed language. So, but we solved the first on-off task, and what we did not is a smooth one. Okay. That's the only slide. Okay, that's an impression of our rules. It's 200 lines of code for the on-off case. And what we basically do, if we look at the first rule, the laser pointer, is that we take an SSL element and retype it to an SCL configuration in this case. So that's just change the type, and so we keep the graph structure of the original graph. So here it's similar. Here we have a rule that transform the enter node and check, okay, it's an enter node, and we also need the action, the end action, and then we transform the test case to the mode because it's very similar in the structure, and added an edge from the mode to the action. That's what we need in the resulting mode. We see it in action.
Can I ask what does the delete do?
The delete deletes the when and the edge, the enter mode. So you delete the original ones and replace it by the ones. Okay. Can you see something? Not. Okay. What you see here is the original graph. We can import that. We cannot import the configuration. And now we apply the first rule that replaces the specification with the configuration. So now it's a configuration, and the second rule matches an enter mode. I think yes. If you see one here, that's an enter mode, and now we replace that. Oh, sorry. And what we get is we replace the test case with a mode and added these entry actions to the edge to the actions. So we continue like this. We have one rule for each action, each element of the original graph, and then we now transform with the check mode. It also creates some modes. So you see there are some more modes like here. So you have duplications at the moment. We have multiple modes should be run, and then it just continues replacing the actions and so on. Then we fuse the modes and add the white edges, and then we end up with something like this. What we also do is some nice visualization of the resulting configuration. So here you have these modes. You have the next mode, that's the action if you have a mode. And then you have these entry action, change display to an empty string constant. And here you have change display to a hello constant. What was missing yesterday was this edge. We noticed that they are missing today, and just one line you have to add. It's not that much. So yeah, and as I said, on-off is the only task because we cannot convert strings to integers. So we are finished here. If you have questions.
How did you do, or did you address ordering buttons? Or
It's done for the modes, I think, because we retype it and then we have the ordering of the test cases, but not for the buttons.
So apart from the string to integer, which obviously your tool, you can't implement that, was everything else complete for the second one?
We started, we have these events and so on, but we stopped as we noticed that we have to do this, and then we do some nice.
Do you have some intuition about this? Do you feel like you could have completed this?
In time, it would be hard. I'm not sure.
Okay.
Could you do the arithmetic to break it up into hours and minutes if you could get it into an integer?
Yeah, we are on strings. We can do a lot. We can do substring and all this stuff. And what we can do is convert the substrings into so that would be possible.
Can you give a short overview of your rules? You have shown one exemplarily.
Yeah.
No impression.
It's always like this. So match one test case whatever you need to connect, and then always delete the old ones and retype some element. In this case, not. As I said, it's 200 lines.
What was this iterated?
This is for the fusion, I think. If you want to you have multiple copies of your modes, and now you want to fuse your modes. And let's work like this. You have two modes with the same name, so they are the same, and then you copy each edge from M1 to M2. That's iterated here for the incoming edges, here for the outgoing edges.
Your rules apply, the rule application is automatic?
No, we have some.
Or you have a control photograph or something?
It's just apply them one after another. So it looks like this.
Okay.
So this is apply this, then apply this. All
Okay,
these brackets means all meshes.
Yeah.
And then we include layout, configuration,
Okay.
and show the graph. It's all very interesting.
So you can natively, these imports will suggest that you can actually read in these models.
You can read in the XMI, so the on-off XMI was no problem. But we can't do this configuration equal. We have some problems with it.
Okay.
That wasn't possible.
Okay.